All right, so we're going to talk about wind erosion now. So something to really point out is that wind erosion happens in dry places for the most part. When you have wet sand at the beach, it doesn't get picked up very easily because wetness is sticky. Water makes sediments stick to each other. So in dry places or on dry sands, that's where we're going to have a lot of wind erosion. And remember, erosion means to move sediments, not break them, but to move sediments. Erosion can cause weathering or can cause the breakdown of rocks, but erosion is just the concept of moving something. It almost sounds like a road, like you drive down a road, right? You move down a road. You don't want the road to break or weather, and you don't want your car to just stop or be deposited on the road. You want to move on the road. So erosion, I don't know, may help. So dry areas are where wind can pick up sands and pick up sediments and cause giant amount of motion. And I'll show you a feature of wind erosion. So you can see how wind erosion causes this strata, or these layers of rocks, to form these weird pockets. Ventifacts, we call them. These are ventifacts. What happens is the wind will rush by here carrying some sand, and that wind will get caught in a spiraling motion, almost like a little tornado inside here, and then it sandblasts, which just means that the wind actually causes the sand to cut and gouge out these ventifacts. Interesting enough, you see it more on lower places than higher places. That could be for two reasons. One reason, these rocks might be harder than the rocks below them. But the better reason, and the more likely reason, is that when wind blows and picks up and erodes sediments, it can't pick them up very high. I've experienced this at the beach where the sand was dry and it was a really windy day, and my ankles were just getting hit by all these pieces of sand. It felt like I was getting little bites on my ankles. But above my knees, I didn't feel anything because the wind wasn't strong enough to pick up those sediments. We'll see how that creates different formations, but here's an example of one right here. So, really, really good and obvious wind erosion causes wind deposition, which we call sand dunes. I can always tell you the direction a sand dune is moving, and yes, they move over time. You see how this is a gradual slope and then this is a steeper slope? The wind always travels from the gradual slope and then it falls down the steeper slope. And this sand dune will eventually walk its way over and over. And you see how this has a flat surface on it? It makes flat surface rocks once this gets covered with water in some type of ocean formation. And we'll show you pictures of that. So here again, we have the gradual slope and then the steep slope. And you can see all the sand is being carried over here and laid along these flat lines over and over and over. What does that cause? We get these layers where we used to have the edge of the sand dune, right? And it forms a new layer on top of it. Eventually sediments build up on the top here, and then they slide down, all right? What happens when sand dunes go over one another? We call that cross-bedding. So this is an area that used to be a desert. These used to be different sand dunes over and over each other. You can see these layers separating one sand dune. Here's one sand dune that used to exist from another sand dune. This area got covered with water, and all of these little pieces of sand cemented together to form rocks. It's called cementation. What causes that to happen is that we end up working with different layers of rocks, and then they over and over cause this cross-bedding. As time went on, this used to be a huge rock, and then it got cut through by wind erosion. So wind erosion caused these layers to first form, then the water caused them to cement together to form rocks, and then more wind erosion came through once this uplifted, and the wind was able to carve these out, causing you to see all these different layers called cross-bedding. All right? So, how can you tell the wind direction? The gradual slope flows towards the steep slope. and that's the slip face there. What do we end up with? We end up with these weird features in deserts. Mushroom rock, an arch, okay? There's the mushroom rock, there's the arches. How does a mushroom rock form? This is gonna be in your Nearpod. Two things, like I said before, this upper layer of rock may be more resistant to weathering than the lower rock. But like I said, when I was at the beach, I felt all the sand hitting into my ankles, and it wasn't reaching the upper part of my body because wind erosion can't lift things very high, especially big things like sand. You may not think of sand as big, but when you compare it to dust, it is. So what happens is the wind erosion can only pick things up so high, so it carves out this little layer on the bottom, bringing it to a really, really fine spot. While all the rocks on the top end up building up, right? They just kind of stay there, and this eventually tips over, falls, and it gets destroyed. Arches are very similar, where we have one layer or one column of really resistant rock. What used to be here was rock. This used to all be rock. And the wind came through and carved everything out, right, through those vent effects. All right, so that's pretty much wind erosion, guys. So if you have any questions, please reach out to your teacher, and hopefully you enjoyed. Good luck on the Nearpod.